right, let's talk about complex fractions. We have, when you see a complex fraction, it looks very strange to you because it's a big fraction. So you might have something like this, where it's just very large. And you're wondering, how do I possibly handle this? So there are very many examples of complex fractions, and I'm going to show you a couple of methods that are going to work well for these. We might have some that have a 3 over x plus 2 over y, and then those fractions are over another set of fractions. Something like that. Okay, so first off, let's take a look at this simpler example here and think about how that's going to work. We have, if you look at this, you can see that this line here is like a big division bar. So we can rewrite this fraction as 5x over x plus 2, and then just put a division and then put the fraction on the bottom, the denominator fraction, x minus 2. Now with this, we have it a little bit simpler. We can use our strategies that worked for regular number fractions and use them here. So we might have 5x over x plus 2 and change it to multiplication. Remember, keep the initial one, change to multiply, flip the second one, so then we'll have x minus 2 over 10. And now we want to reduce before we multiply as usual. So we'll think 5 goes into 10 2 times, and then we're left just multiplying straight across, x times the quantity x minus 2. And in the denominator, I have a 2 times the quantity x plus 2. And there's my solution. This method we'll call method 1. And it's only going to work if we have a single term for the numerator and a single term for the denominator. And that's important to remember. Okay, here's our next complex fraction. And this one has several terms in the numerator. So I see one term here, a second term here, a third term here. So I know I can't use method 1 right away. I could add these 3 terms together, but remember that requires us to get a common denominator for the numerator for all 3 of these denominators, and then we would have to do the same thing for the denominator to make it into one term. So we have another method that's much easier for situations like this. I've highlighted all 6 denominators that I'm thinking about for my problem, and what I want to do now is try to find a common denominator that's going to work for all 3. All 3 in the top, all 3 in the bottom. So LCD. For the numerator, I know I need the numerator set. I know I need an x squared. And then I'm looking at this next one. It's xy. I already have an x here in the x squared, so I just need to put a y on there. And then for the last one, I need a y squared. I already have one y, but if I square it, then I have enough. I have x squared, y squared, then for my common denominator. That will work for all 3 denominators in my numerator. When I look down here at this denominator, the second set, I've got an x squared, xy, and y squared, so I can see that my x squared, y squared is going to work for the top set and the bottom set. So I've got a common denominator for all 6 denominators in my problem. Now, what I'm going to do with that common denominator is make it into a form of 1. So I'm going to have x squared, y squared, over 1, just because it lines up better with my fractions, over itself. So x squared, y squared, over 1. This whole thing now, it's important to notice, this whole thing is a form of 1. And now when I know it's a form of 1, that means I can multiply it by anything, and I'm not going to change the values. I'm just going to kind of essentially build it up. So I'm going to multiply it by that original complex fraction, and what I'll have to do then is remember that I have three terms up here, so this numerator part has to distribute to all three terms. Same for the denominator. It'll distribute to all three terms. Now I'm going to rewrite that so that we can see what it looks like when we have it all worked out. I'm going to use some color, so hopefully that'll help make things clear. This 2 over x squared is my first term from above, and then I'm going to be multiplying it by my common denominator over 1. So it's going to be the x squared y squared. I'm distributing, remember, so it'll multiply by every term. And then I have minus 1 over xy, and then I'm going to multiply that also, distributing again, x squared y squared over 1. And then I have another minus 1 over y squared, and it is also being multiplied by x squared y squared over 1. That's my numerator. It looks big and ugly, but we'll be able to reduce things very quickly after this step, and it'll look much, much better. So for my big denominator, I have 1 over x squared, and that I'm going to multiply by that LCD that I need to distribute, x squared y squared over 1, and next term is minus 3 over xy. I'm going to multiply that by x squared y squared over 1. And my last term was a plus 2 over y squared. I'm going to multiply that as well, x squared y squared over 1. So now what I've done is taken my original problem, looked at the 3 denominators for the top, 3 denominators for the bottom, came up with a least common denominator, and then I distributed it, multiplied the common denominator over itself by every term essentially. So I have the numerator gets the common denominator on every term, the denominator gets the common denominator multiplied by every term. Now comes the fun part. I'll find where my pen went. There we go. Okay. Now I'm going to use another color so we can see it. I am going to reduce. So this x squared and this x squared reduce. This xy goes into x squared y squared, and I have just an xy left over. The y squareds reduce. Down at the denominator, the x squareds reduce. Xy, again, I get an xy left over, and then y squareds reduce on the right. That's the whole purpose of multiplying by that common denominator over 1. We want every single denominator to be reduced away so that all we have left is just the top levels. So let's rewrite. What do we have now? I've got 2y squared, that's all that's left for that first term, minus, and here all that's left is 1 times xy, so just an xy. And this last term on the numerator, I have negative 1 times x squared, so minus x squared. That's my whole numerator, that's all that's left. My whole denominator, let's take a look. First term is just all y squared. And second term, negative 3 times xy, so minus 3xy. And the last term on the denominator is 2 times x squared, so plus 2x squared. Now I've gotten it so much more simplified, but now at this point I want to see if I can factor my numerator, factor my denominator, and if I have any like factors I want to reduce them away. So let's try it out. For my numerator, I want to do a sum product chart. So my sum is going to be negative 1, my product is going to be 2 times negative 1 or negative 2. I'm looking for things that multiply to give me negative 2 that add up to negative 1. So I'm thinking, well, 2 times 1 gives me 2, and those are 1 apart. And if I put my negative on the 2, then when I add them, I will get the negative 1. Now I have a lead coefficient here, so I cannot use my shortcut. No shortcut. And so then I will have to plug it in, and I'm going to do it over here so I can do this like as scratch work. So I have 2y squared minus 2xy. I'm taking the variables from my middle term and putting on the coefficients from my sum product chart, and then I have plus 1xy minus x squared. Now I'm looking to do factor by grouping. First group, I can pull out a 2y, and I have left y minus x. Good. And then the second pair, I want to pull out, it looks like there's just an x, and a positive x will work just fine. Pull that out, and I have left y minus x again. Remember, my parts inside my parentheses has to be the same factor, so I can factor it out to the front. So I have, whoopsie, malfunction in my brain there. So I have y minus x for the factor that I'm factoring out now, and what's left over, 2y plus x. So now I have my numerator factored. I'm going to write that in my problem list so I can have it in that order, y minus x, and then 2y plus x. Now I want to factor my denominator. And so I'll use the sum product chart again. My sum is -3, my product is +2. Well, I know 2 times 1 is 2, and those add up to 3, but I need them to add up to -3. So if I put both of them as negative, then when they multiply, I get a positive, and their sum will actually be a -3. My other choice, of course, was 2 times 1, and that comes to a +3, which doesn't have the right sign. So I need to go with the negatives for this one. I can use my shortcut here, but because I have the y squareds and the x squareds, I'm going to use the long way just so that I make sure I get my middle terms right and I get my factors correct. Or I could look at the numerator and see what I did there and use that same pattern. But I'm going to go ahead and do it the long way just so you can see it works. So I have -2xy minus xy plus 2x squared. Now factor by grouping again. First pair, second pair. For the first pair, I can pull out a y, and I have left y minus 2x. And then the second pair, it looks like I can pull out just a -x, and I have left y minus 2x. I've got a factor in common. That factor in the parentheses is the same on both, so I can pull it out, y minus 2x, and I have left y minus x with a flare. Now my denominator, y minus x, y minus 2x. And when I look at them, I see that I do have factors in common, and it's this y minus x that's the same on both. And so I can reduce that factor away. Remember, the entire thing has to match, the entire factor. So 2y plus x over y minus 2x is my simplified answer, and I can't reduce any further. I'm hoping those 2's aren't calling your name, because I would have to be able to factor a 2 out of the whole numerator and out of the whole denominator and then be able to reduce. So I cannot reduce any further. And that's my final solution for this problem. Now it's your turn. So take a look. There's level 1, 2, and 3. Pick your level, and I will pop up the answers here briefly. So make sure that you're pausing the video here. Alright, here's the answers for level 1. I showed you 2 different methods here, so you can pause the video here if you want to take a closer look at those. The LCD method that we did on the second example works just as well as the first example, where we change it into a division problem. If you're interested, if you're at a point where you can comprehend all of this, because I know sometimes this is more than enough for you to get through, you can look at how I do a check on the problem. I choose a number. In this case, I chose x is 2 and y is 3. And then I plug it into the original problem, and I plug it into the answer. If it comes out to the exact same number for both, it means that my original and my answer are equivalent, which is a good place to be because it means that I did them right. I may not have reduced it all the way. The two are equivalent, the original and the answer. Here's level 2. Method 1, I just wrote out what you would do for it because it's a longer process. I did not want to do it. And then I showed you the steps that I did. One thing I didn't show you a second ago is if you have a negative here, you would want to change it to a positive and move it up to the numerator so that you don't lose track of those. That's a good strategy. See how I have it up here with the 5? Then I don't lose track of it when I start reducing and stuff. That -5 is going to stay down to my answer. Okay, scroll down just a hair so you can see the last part there. And go ahead and pause if you need to look at this any longer. There is level 2. I think I'll scroll down just a little bit more so you can see the whole check. 2 methods, I showed you both of them. This is actually, I think, the same as the previous problem on the level 1. Here's your second one, your second problem, showing you the whole process, including the check. When I went to do the check, I wanted to use 2 because it's a nice small number, but it won't work. And if you look back here, you'll see if I stick 2 in right there for that denominator, it's going to give me a 0 for a denominator, and I can't use that. So I chose 3 instead and used that for the original and for the answer. Okay, there's the challenge problem. You could use method 1. I did not want to because I had 2 separate fractions, so I was like, nope, forget it. I'm going straight to method 2. My LCD is simple, and I'm showing it with all my time savers where I just multiply. I show that here, and then I show multiplying every term, whether it has a fraction or not. Every term is getting multiplied by that. And then I can just show my reducing on that original problem, and bam, right down there to my answer. And I'm showing my check here. I was able to use my favorite number 2 again, and it worked out. Here we go. This one's method 1. I lost my numbers here. You'll have to look at your paper, but I was able to reduce, and there's my check at the end. And I think we're ready to go back to, right, the next thing I want to show you is negative exponents. And if we can recall, if I have x to the -1, remember it's the same thing as 1 over x to the +1. When we move something down over the division bar, its sign on its exponent is going to flip, so this becomes a +1. So what I want to do is think about each of these as a separate fraction. Because they have plus in between, I can't just move everything down. I have to think of them as separate fractions. So I'm going to write it x to the -1, think of it as over 1, plus 2xy to the -1, think of that whole thing as over 1. And then I have x to the -3 over 1, and then minus x to the -2y, whole thing over 1. And what I'm going to do now is just move the pieces that have a negative exponent. My 2x, let's pull that to the side and think about it for a minute. I have 2xy to the -1 all over 1. Now if I'm looking at that, the only thing that has a negative exponent is the y. The 2 has a +1 implied, the x has a +1 implied. So all I'm going to move, my pen went on a little vacation there, does that sometimes. The only thing I'm going to move is the y. So it's going to stay 2x in the numerator, and then my y moves down, and it's now y to the +1, so you can just write it 2x over y like that. Okay, so let's rewrite all of these so that we have positive exponents. So I have 1 over x for the first term, 2x over y for the second term because I moved just the y. The denominator is going to be 1 over x cubed, and I'll have minus y over x squared. The only one with the negative exponent here was the x. Now that everything has been moved, we can even put little arrows here just so you know which ones we're going to move. I might want to think about moving my negative. Do you see the negative on the denominator? Think about moving it up to the numerator. And then the next thing I want to do is find a least common denominator. It's going to be x cubed y. And you can see there I need an x, here I need an x cubed, here I need an x squared. So of those three, I'm going to take the highest exponent, and that's where I get the x cubed, and then the y has to show up as well. So x cubed y, what I'm going to do with that then is multiply every term. This is my shorter version of the problem. So x cubed y over 1 times every single term in the problem. Okay, the next thing I want to do is reduce. So I'm looking at this as a little group that's being multiplied, the same down here, the same over here, and here. So what I'm going to do here is the y and the y reduce, the x and the x cubed, I'm left with x squared y now. And then on the bottom, the x cubeds go. Over here, the x squared is going to leave me with an xy. And I believe I've got all my reducing done. So we'll go back to trying to figure out what we have. So we're going to rewrite. So for the first pair of parentheses there, I have just x squared y times 1, so just x squared y, and then a plus, and then I have 2x times x cubed. So that's going to give me 2x to the 4th. And all of that is over right here. All I had left was just a y times 1, so it'll be y. And then here I have negative y times xy, so negative xy squared. Now I want to think about reducing. And for the numerator, I can see that I can factor out an x squared from both terms, and what I'll have left is a y plus 2x squared. Okay, and then looking at the denominator, I see I could factor out a y from both terms, and I would have left a 1 minus xy. Now my two factors here don't match, and the things I factored here don't match. There's nothing I can reduce, so you could leave it in either form, but this is your answer right here. And I'm not able to do anything more with that in terms of reducing. So you could leave it in this form multiplied out, or in this form where it's factored out. Either one is fine. Okay, we have some there for you to try out. So if you like, go ahead, give those a shot, pause your video, and then I'm going to put up the answer. Okay, here's level 1. Here's how it looked after I moved things around, and you can see where I found my common denominator of x squared, y squared, and then I multiplied every single term by it and reduced. I did have to rewrite this so everything had positive exponents first. And then at the end I was not able to simplify any further. Here's level 2, and I'm showing a check on that if you're interested in learning how to do that. You can pause anywhere you want to take another look at these. And then here's the challenge problem. I did it 2 different methods. Method 1, I wanted to show at least one time the long way because these were close in their denominators, so I saw that I just would have to multiply by 2 over 2 to make these have both the same denominator. So once I did that, then it was easy for me to combine my numerator into one term. My denominators ended up having the same denominator for both fractions, and so I could just combine them very easily. At this point then I'm just keep change flip, so it's 9 over 2x times now, and I flip this over x over 4, and then I can reduce the x's. I come up with 9 over 8. I did it by method 2, which works just as well, and generally I would probably just go to that method, but this one had a very simple set of denominators, so I was tempted to use method 1. I ended up with 9 over 8 as well. I decided to check, to show you a check, and I used x equals 2, plugged it into my original problem, and plugged it into my answer. Since there was no variable on the answer, I just divided that and came up with 1.125, which is the same thing I got when I plugged in x equals 2 for my original problem. So there's a third verification that I solved this one correctly.